All right, so for the next examples, we're going to be asked to name the parent function, then identify any transformations that are taking place, and then give a sketch of the graph. So what I would like to do is do our own sketch and then put it into Desmos just to make sure that it looks nice and we see what's actually happening. So parent function here. I'm hoping it's pretty clear to you that the parent function is the quadratic x squared. Okay, so if we have that, then notice that we're adding 2 to that function. So x squared plus 2, that is going to give me a vertical shift of 2 units. All right, so x squared, let's go ahead and do a table for that. Let's do we have x and then f of x. Usually you're going to pick, -2, -1, 0, 1, 2. So let's try that here. Again, that's for an ordinary function or a parent function. Those are probably good choices. So -2, right, remember the parent function here is just x squared. So -2 squared is 4, -1 squared is 1, 0 squared 0, and this is 1 and 4 again. So I have the point 0, 0. Then I have 1, 1, 2, 4. And on the side, I have -1, 1, and -2, 4. Okay. So this is my parent function. It's not easy drawing this, so feel free to make fun of my drawings. All right. So that's my wobbly parabola there. And then let's pick a different color and do the adjusted function. So x, and let's call this g of x for the new function. Okay. So we'll do the same thing, -2, -1, 0, 1, and 2. Okay, so remember now we're doing all of this. So x squared plus 2. So basically we can take all of these values and just add 2 to each one of them. So 6, 3, 2, 3, and 6. Or if you'd rather, you can plug every single one of them in. Oops. We call this guy g of x. So g of x is x squared plus 2. Okay, so that's where we're getting those numbers from. All right, so my ordered pairs are -2, 6. Then I have -1, 3. I have 0, 2, 1, 3, and 2, 6. So let's see if I can't draw an okay curve here. Okay, so that one's not too bad. So you see that all I've done is just taken the parabola and shifted it up 2 units, right? This point went up 2, this point right here went up 2, and so on. That's all I've done. So let's hop over to not GeoGebra. Let's go to Desmos. Right, and I want to do the parent function, which was x squared. And then let's do the new function, which is x squared plus 2. And you can see, same parabola, just shifted up 2 units. Okay? All right, so let's take a look at another example here. Here we have negative of the quantity x plus 4 squared minus 1. Okay, so what kind of things are going on? Well, I'm adding 4 directly to x. So what does that do? That's a shift horizontally, and it goes left 4 units. Then I have a subtract 1 on the outside here. That affects the y, or the vertical direction. So it's going to go down 1 unit. And then this right here, right, that negative in front of the entire x plus 4, that's going to shift over the x axis. Okay, so let's just go back up here real quick. It says if I put a negative on the outside of the parent function, not directly on x, right? So that's outside the parent function, that's reflected over the x-axis. Okay, so we have reflection over x-axis. Okay, so let's do the original function, right? What is our parent function? This time, I guess I'll call the parent function g of x. Okay, so g of x this time is also a parabola. It's still x squared. We just got done plotting that, so we know what it looks like. Hopefully I can execute it a little bit better this time. Okay, so that's basically what it looks like. Now I'm going to suggest that if there is a reflection, you do that first. So I'm going to do this in steps. Okay, so I'm going to reflect over the axis. So it's going to do this. Right, there's a point there, Then the other points would be -2, -4, 2, -4. Okay, so it's going to reflect over this axis. Okay, so it's going to look like that. Then I'm going to take every single point, move 4 units to the left, and down 1. So I'm going to take this point right here, and I'm going to move him 4 to the left and down 1. So how about I do this? Let's do right, the red one there, move to the red. Then let's do a purple. So this point right here, move left 4, down 1. Okay. Let's do a yellow point. That'll be this guy. Left 4, down 1. Let's do a green. Left 4, down 1. And what do we not have yet? Let's do maybe a gold. So this point right here, left 4, down 1. Okay. So my new function, let's do silver, I guess, would be right here. Okay, so I kind of tried to color code those to show you where each one went. That right there is that function. And if I go to GeoGebra, I'm sorry, to Desmos, I keep saying the wrong one. We can again see the red is our parent function, x squared, right? And the blue is the new function that's been shifted 4 to the left and down 1, and then flipped over the x-axis. All right, so here's yet another example. This time we are looking at an absolute value function. So our parent, whoops, let's change colors here. It's a little easier to see. Our parent function is, and again, I'm going to use some other name, absolute value of x. So how is that being changed? Well, I am subtracting 2 from the x directly. That's going to do opposite of what I expect. So that's going to shift right 2. And I'm adding 4 basically to the y, which means I'm going to go up 4. All right. So what does a basic absolute value function look like? Well, we can go ahead and do a table if we like. So we have x, and we have f of x. And I'll do our same numbers, -2, -1, 0, 1, and 2. Okay. So absolute value, remember it gives us the distance from the origin or from 0. So if it's a negative value, it just returns the positive value. So I get 2, 1, 0, 1, and 2. If I plot those points, right, I have 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. So I have this. Okay. So this is f of x. Now, I'm sorry, that's our g of x. If I want to do all the translations now, I need to shift this whole thing right 2 units. And then I need to also shift up 4 units. So everything goes right 2, up 4. Okay, so I moved this point here to that. Then this point right here is going to go right 2, up 4. This point right here is going to go right 2, up 4. And you can see I'm getting the same shape. So you can expect, right, if these points went over 1, up 1, over 1, up 1, that these are going to do the same thing. We get this. Okay, so not too bad. Let's go ahead and take a look at Desmos. So this time I need absolute value of x. Oops. I think it's going to take me back up there. Okay. And then I need, again, the absolute value of x minus 2. And then plus 4. Okay. And that's exactly what we had. This is a similar example. The difference being now that we have a flip, right? That negative there tells us that we are going to flip or reflect over the x-axis. Okay. We add 5 directly to x. That is a shift left 5. And we're subtracting 3, which is a shift down 3. Okay, so we have our basic absolute value function. Right, we already knew what that looked like from the previous example. So again, if there is a reflection, I suggest doing that first. So I'm going to reflect this over the axis. Okay, it's going to look something like this. Okay. Now I need to take, and again, there's the point here, 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 and here. Now I need to take each one of those points. I need to shift left 5, down 3. So left 5, down 3 for the one that's at the origin. Okay. Now I'm going to take this point, 5 to the left, down 3. It's going to go right there. You can imagine that the one opposite that point is going to move right here. And then because of the basic shape, we know it's going to look like this. And you can check, right? You can move each one of those points left 5, down 3. So this is the parent function, and this is f of x. And again, let's go ahead and jump over to Desmos. All right, this time we needed absolute value of x, and the other one is minus absolute value. And we need plus 5 and minus 3. And again, exactly what we just found on our graph. Okay. All right, here's another example. This time we have a square root function. So our parent function is the square root of x. So what does that look like? Well, we can do a table. And I'm going to be very strategic in the values I pick here for x, because I want numbers that have nice square roots. So I'll pick 0, 1, 4, and 9. So that's going to be square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So I plot those points to see what the function looks like. And this is what I get. Okay. Now I look at the transformations. Now I have to be a little careful with this one. So inside here, notice I have minus x plus 1. I'm going to slightly rewrite that. I'm going to rewrite this as the square root of negative x minus 1. Now, why did I do that? Well, now this is being directly affecting the x, and this is directly affecting x. That negative on the outside of the parentheses tells me that I am going to flip or reflect over the y-axis. Subtracting 1 means I move right 1. And then on the outside, adding 4 means I go up 4. Okay. So first thing I'm going to do, and by the way, if I took that negative out there, if you don't like how I did that, multiply the negative back in, right? So I have this. This is minus x plus 1 if I distribute the negative. So I just did the opposite. I factored it out as instead of distributing to get to the other result. And again, I did that because I'll scroll back up here, right? The rules, they tell me that if I apply a negative directly to the x, that reflects over the y. But in order to do a shift, I have to add or subtract directly to x. And notice they're in the parentheses. So I had to write it that way to get the correct direction. Okay. So first, I'm going to flip everything over the y-axis. So now I'm going to have this point here, here, and here. Okay. So that's the first change. Now I'm going to take every single point there. I'm going to move them right 1 and up 4. Okay, so I'm going to start here. I'm going to go right 1, up 4. Okay. Now I'm going to do this one. Right 1, up 4. Oops. Okay. Now this guy. Right 1, up 4. And finally this one. Right 1, up 4. So this should be the graph of my function now. Yeah, I almost got my point there. All right, so let's go over to Desmos and make sure that we did this all correctly. So I have square root of x, I have square root of minus x plus 1 plus 4, And you see that that does exactly what we said it was going to do. It's going to flip it over, shift it up 4, and right 1. All right, here's the last example of this type. We have a square root function once again. The only difference is now we have the subtraction or the negative on the outside of the radical. So that is going to affect the x-axis flip. Okay, so this is flipped over x-axis. All right, so what else are we doing here to this function? Well, subtracting 2 directly from the x is going to move right 2. And adding a 1 on the outside affects the y. That's going to be up 1. So we have our original square root function. Once again, I'm going to take and flip this over the x-axis. That's going to be this. And then each one of those points, I'm going to shift up 1, right 2. So I should have this graph. And if I hop on over to Desmos, we'll see it much nicer. Okay, those are their 2 graphs there. All right, so hopefully that helps you with understanding the differences and how to move functions left and right, up and down, right translations, and flipping them over axes.